Hello again, Abigail. This is the video I prepared for your second question, which is 7.151, and this pertains to also a graphing problem. And your specific question was that you were a little bit confused about graphing cubic roots. They are very similar to square roots, the problem that that you had a question about previously. The only difference is if you recall from the content of the class that when you have square roots, you can only have positive numbers under the square root. But when you have cubic roots, you can actually have negative numbers. So in this case, in order to graph any function, as I previously told you, you have to make sure that you know what values of, you would substitute values for x and get values for y, which is f of x. So in this case, because x could be any number, it could be a positive or a negative number, you could choose any number. Now for this specific reason, they started, for instance, with -4. If you do -4, that is -8. Why did I want to choose -4? Because it gives me -8. -8 is basically -2 raised to the power 3. Okay, -8 is -2 raised to the power of 3. Remember, with cubic powers, roots or powers, I can have a negative number. I can use a negative number. So if I have -2 raised to the power of 3, the 3 and the 3 would cancel, leaving me with -2. Then they chose 3 because 3 minus 4 is -1. Right? So 3 minus 4 is -1. I can take -1 outside of the cubic root as well, because it's just -1 raised to the power of 3. 4 would give me 0, and they chose to do multiple numbers here. The reason why is because if you look at these graphs that you have, if you look at these graphs, A, B, C, and D, you can see that they are not simply just simple curves. As a matter of fact, they show a pattern, and so for that reason you have to choose more than one point. But even if you chose 3 points, you might get an idea of what the graph looks like. You can choose 5, you'll get 1. You can choose 12, you will get 12 minus 4 is 8. 8 is 2 to the power of 3. You can take 2 outside of the radical because the power of 3 and the cubic root will cancel. And then what you're going to do is you're going to go ahead and plot them on the graph. -4, -2, right? You're going to plot them on the graph, and then you're going to connect the dots to get your curve. And then you're going to determine the domain. Now, as I said, the x values in this case, they're limitless. They don't have to be positive. They can be negative or positive, and for that reason, your domain would go all the way from -infinity to +infinity. Whenever you have infinity, you don't use a closed bracket, so it's always like this. Okay, not a bracket, it's a parentheses. Now you want to also look and determine what is the range of the y values. So if you look over here, you can see that it could be going even down, and it could, even down further, and it could go up higher in here in terms of y. So there's no really limit for y. Because it's decreasing here, and it is still increasing, so it could go up to a higher y value, or from here it could start from a lower y value. So therefore it's also going to be -infinity to +infinity. Now this is the example, and this is very much similar to the example. So I want you to go ahead and try solving this, and please reach out if you have any more questions.